Assalamu alaikum to you all. So far in this course, we have learned about two data structures, namely singly linked list and doubly linked list. We have learned how to implement these data structures. Now in this, our third lecture, we are not going to develop a new data structure. Rather, we are going to improve on the ones we have developed so far, particularly the doubly linked list. And we're going to do that by studying two very important interfaces, which are Iterator and Iterable. These are two interfaces in the Java library. So this is the outline of the lecture. First, we will understand what is an iterator, and then what is the iterator interface. So here, what is an iterator? Iterator as an object, what is it? What does it do? And then we look at the iterator interface. How do we use iterator to iterate through a collection or to traverse a collection? Okay, using the iterator of that collection. And then the important one, how do we implement an iterator? Because we want our doubly linked list, for example, to have the advantages that we're going to mention in having an iterator. So how can we make our doubly linked list to have an iterator? Okay, and then we will move to the second interface, which is called Iterable. What is this interface? And then we will see that this interface actually is very much related to the for each statement. I'm sure you are used to the for each statement from your programming 2 course, and we will see that actually behind the scene, before you can use for each statement, your collection must implement the iterable interface. So the two points here are very much interrelated. Okay, and finally we will briefly look at the advantages of implementing the iterable interface. Yeah, this is the plan for this lecture. Let's get started. What is an iterator? Okay, iterator usually is an object. So what does it do? So an iterator is an object that allows for the iteration of the elements of a collection one by one. Another word for iteration is traversal. So it allows you to traverse a collection, meaning go through the elements of that collection one by one. Okay, and there's a good news, which is that all Java collections, we have seen a number of them so far. We have seen ArrayLists, we have also seen linked list, and I think we discussed about the vector class. There are many other data structures or collections in the Java library. You can find them under the collections package. Now, all of those collections, they can actually provide an iterator. So, okay, and once we have an iterator for a particular collection, we can now use it to traverse that collection. Okay, so that is the good news. Our singly linked list and doubly linked list, for the moment, they cannot provide an iterator that can be used to traverse their objects. And that is the purpose of this lecture. By the end of this lecture, they will, particularly the DLL class, will also, like ArrayList, will be able to provide an iterator which can be used to traverse through the elements of the linked list. Okay. Now, an iterator object for a collection is obtained by calling the iterator method. Okay, so basically what we are saying is, if you have a collection, how do we get an iterator of that collection? Because for you to be able to traverse through the collection, you need an iterator object. So how do you get the collection? How do you get the iterator object? Okay, you do that by calling a method called iterator. I hope it's not confusing. The method itself is called iterator. Of course, all methods start with small letter. So the method itself starts with small I, and of course it will have the bracket at the end. So any collection that can give an iterator will have this method. And if you call it, you're going to get an iterator object. Okay, we will see an example of what I mean in a moment. This is the signature of the iterator method. Okay, as you can see, it has no parameters, so it doesn't receive any input. But as you can see, the return type is a generic iterator object. So the generic type here depends on the type of the elements that are stored in your collection. So if you have, for example, an array list of integer, it will give you an iterator of integer. If you have an array list of string, it will give you an iterator of string, and so on. So this type T depends actually on the actual element that you stored in your collection. Yeah, but as you can see, the method will give you an object. You can see the capital I here indicate that the object you're going to receive implements this interface. We will see the interface in a moment. Okay, so if you have a collection that can provide an iterator, just call this method and it will give you the iterator object. I'll show you what I mean in a moment with this example. Suppose we create an array list of string. So array list of string, LST, equal to new array list of string. And let's put some string elements inside our array list object here. So suppose we say, for example, list.add Amr, list.add Ali, list.add Othman, and list.add Samir. So we have added 3 names into our array list here. Now suppose you want to get an iterator of this object, this array list object. How do we do that? As I mentioned in the last slide, you just call the iterator method of your collection. So the LST here, it has a method iterator, which you can call like this. So you say lst.iterator, and it's going to give you an object. So in what type of variable are you going to save that object? It is going to be of type iterator of string. As we saw in the previous slides, the signature of the method is iterator of t. So in this case, we know what the t is. It is a string. So you should define a variable iterator of type string to receive the result that will be returned to you by the iterator method. So this is how we do it. So this is the iterator object, and this object can be used now to traverse through these elements. But before we do that, I will first give further explanation about what is actually inside this object. We need to look at its methods. Okay, so that's the question here. How then can we iterate through the elements of a collection like the LST we have above after obtaining its iterator? Okay, so the iterator object is IT. How do we use it to iterate through the elements of LST? It says here, for that we need to first study the methods of the iterator interface. So let us look at the iterator interface. The iterator interface. The interface has 3 methods as shown and explained below. Okay, this is how the interface is. It is inside java.util, so normally you will have to import it if you want to implement it for your class. So public interface iterator of generic type T. It has three methods. A Boolean method has next method, which will return an element, and remove method. Let us explain these methods in detail. Starting with the hasNext method. The hasNext will return true if there are more elements in the collection to be traversed. It will return false otherwise. Let me show you this diagram because that will explain better. The idea is when you first get an iterator object from a collection, you should imagine that the iterator object is like a pointer, similar to the temp pointer that we have been using to traverse through our linked list. So assume that that pointer is initially pointing to the first element in the list. Okay, so the hasNext method will return true if this pointer is not null, meaning there are more elements to traverse. Okay, it will only return false after it has reached the end of the list. Okay, so that is the idea of the hasNext method. Normally we use it to know if we can get more elements from the collection. We have not finished the traversal yani. Okay, so initially the iterator will be pointing to the first node in the collection or first element. Okay, what about the next method? Next method does two things actually. First, it returns the current element from the collection, the element that is being pointed by the iterator currently. Okay, so in this case, for example, it will return 0. Second part is it will move the iterator to the next element. So remember I say imagine the iterator to be like a pointer. So it will return to you 0 and also move to the next node. So pointer now is pointing to 1 in this particular example. Okay, if you say next again, it will give you 1, but at the same time it will move to 2. So this is exactly as we have been doing in, if you recall, in our linked list. We have temp, which initially equal to head. So if we say, if we want to get the element, for example, we want to print, we will say print temp.info and then temp equal to temp.next. Okay, something like that. In fact, we're going to use the same idea to implement our the interface for our doubly linked list. Okay, so those are the two important methods. There is another method called remove. It's not very often that we use it, but it is there in the interface anyway. So if you are implementing the interface, you have to implement the method, whether you like it or not. You can make the method to be empty if you don't really need it, but it has to be there, otherwise the implementation of the interface will not be complete. So what does it do? It says removes from the collection the element returned by the last call to the next method. So before you can call remove, you must first of all call next. Okay, if you call next, rather if you call remove at this initial point, it's going to return an error. But suppose after you say next, so that you obtain 0 and the iterator has now moved to 1, if you now say remove, it will remove the 0 from the collection. Okay, so the list will not have 0 element anymore. Okay, this is the idea. It removes the element returned by the last call to the next method. So if you say next, so that pointer move to the element here 2, and then you say remove will remove 1. Okay, You don't have to be removing elements from your collection. In most cases, you don't need to. Okay, but the method is there in case you need to use it. All right, so these are the methods of the Iterator interface. It means the object that we obtain in our previous slides, it has these methods. How do we use this method, therefore, to iterate through our collection? Okay, so to iterate through a collection using its iterator, the methods of the iterator are used usually in a while loop, similar to the following. You will say while iterator has next. So normally you use the has next method as the condition for the while loop. While there are more elements to iterate, get the next element by calling the next method. So iterator.next. So this will give you an element which you can now process as you like. For example, you may want to print it. If there are numbers, you may want to add it to a sum or do something else. But basically, you are able to obtain the next element. Okay. Then you go back and say, are there more? If yes, call the next method to get the next one, and so on. So you can see this will give you a way to traverse through the collection by using its iterator. Let's go back to our earlier example so that we can complete it, since we now know how to use the iterator to traverse the elements. We already have created the list, if you recall, a list of string, array list of string, and we have added elements. And I was saying, how now do we use this iterator object to go through these elements? Simple. As this loop says, we will say while it has next, t element equal to it.next. So you see here, next initially will give us amber. So this element initially will be amber. So for example, we can say print amber, and then go back and check, are there more? If yes, it.next. So next is going to give us Ali. Okay, print Ali, and then go back and ask, are there more? Yes, and you're going to get Uthman. Print the Uthman. Go back, are there more? We're going to get Thamir. Okay, print the Thamir. But now, when you go back, the has next is going to say false. There are no more. Because at this point, the iterator will be at the end of, not at the end actually, outside the list. It has exhausted all the elements of the list, and it is null at the moment. So this will stop the loop. This is basically how to use the iterator to traverse through a collection. So first you have to ask the collection, please give me your iterator. How do you do that? By calling the iterator method. So you say list.iterator. It will give you an iterator object. Save it in a variable. Of course, this it is just a variable name. You can use any name you like. Okay, so, but the type has to be iterator of type string in this case, because the array list contains string elements. So the type here has to be iterator of string. Okay, now once we have this, then we use a while loop to go through the elements of the collection. Okay, now just to make sure you really understand this example, I'm going to show you in real life an example similar to this so that you are comfortable how to use this iterator. Before we move to the next stage, asking how do we now implement this iterator for our own linked list. So I'm going to leave the slide for the moment and go to NetBeans. In the NetBeans, I have an example here called test array list, the same as the one we saw in the last lab, but just make a minor modification to use iterator. So This time I choose to create an array list of integer called lst, and I have added some 4 integer values. Okay, 4, 5, and then I add 6 at position 2. It's going to be at position 2 anyway, because it's going to be position 0, position 1, and 6 will be in position 2. And now 9 in position 0. So actually our list at this point is containing 9, 4, 5, 6. Okay, you will see when we print it, it's going to contain 9, 4, 5, 6. This is the content of the list. Okay, so we can print the list, of course, because it has a 2 strings. So if you wish, you can print the elements, all the elements directly, just by saying print lst. But suppose I want to print them one by one, let's say 1 per line. In that case, I have to use an iterator, or for each, which we shall explain later, to traverse the elements one by one. So how do we do that? We ask our LST to give us its iterator object by calling the iterator method. This time the type has to be iterator of integer, because our list contains integer values. Okay, so save it in variable it, and then as I explained in the slide, now we're going to use a while loop. So we'll say while it has next, okay, system out of print line it.next. So you see, in fact, you don't even have to save this in a variable if you're not going to use it maybe to add to some variable. We just want to print. If you want to print, just say print it.next, because this next method is going to give you the next element, then the next one, then the next one, and so on. Let me comment the rest of the example just to show you how this works. Okay, so suppose we stop here. You will see that the output, first it will print all the elements in one line like this, and then it will print the elements one per line, because we're using print line here. Okay, and we are getting the elements by calling the next element of the iterator. Okay, let us run this file. Run file. Okay, so this is the output. As we said, first it printed all the elements because we printed the list, but using the iterator we are also able to print the same elements, but this time one per line. I hope this is clear. Okay, let's go back. Another thing we can do, instead of just printing the elements, maybe we want to add them up to find the sum. So again, iterator give you a very easy way of doing it. So you initialize your sum to 0. Now you cannot use this iterator again. This is very important to note, Shabab. Once an iterator has reached an end, it is dead. You cannot use it again. But you can obtain another one by calling the iterator method. Okay, so this is what I'm doing here. Okay, it equal to list.iterator. Okay, because you see, by the time this method return false, the iterator is null. Think of it like our temp has started from a head and it has gone to the end of the list and has become null. It cannot give you anything more. It has reached its end. Okay, so to bring it back to the beginning, you actually have to call the iterator method again. So it equal to list.iterator will give us a fresh iterator, okay, assigned to the same variable, okay, but now it is pointing to the one to the first element in the list. Okay, so the idea here is to add the elements. So what do? We say while it has next, get the next element, but this time instead of printing, add it to the variable sum. Okay, so here sum plus equal it.next means we are adding the element that we obtained from the iterator to the sum. This is the short way of doing it. If you prefer, you can say sum equal to sum plus it.next. Okay, this is the other way of doing it. Okay, so obtain the next element, add it to the current sum. The result you get, put it back in sum, and then go and get the next one, and so on. So you can see that by the end of this loop, our sum variable here will contain the sum of these elements. Okay, let us run the program again to see what will be the output. So run file. Yeah, so the sum is 24. Okay, it's very easy to check because you can see, for example, 9 plus 6 is 15. Okay, plus 5, 20, plus 4, 24. All right, so that is basically the idea of iterator. Let's go back to our slide. Okay, so we have seen so far how to use the iterator of a collection to traverse through the collection. Unfortunately, our data structures, the ones we have developed so far, the singly linked list, SLL class, and the doubly linked list, DLL, they do not have this facility at the moment. We cannot call the iterator method because, as we all know, there is no such method in our DLL class, for example. But can we improve it so that it can provide us with an iterator object? Obviously we can, and this is what we're going to learn next. So the iterator interface is normally implemented by a collection using an inner class within that collection. Okay, so it's not the DLL class, for example, that will implement the iterator interface. No, it is an inner class within the DLL class that will implement the iterator interface. Okay, just like we have the DLL node class as an inner class inside the DLL class, the same way we're going to have another class inside the DLL class. So it's an inner class, but that class will implement the iterator interface. Okay, so that's what I'm saying here, that for example the following implements the iterator interface for the DLL class. So you're going to have this class as an inner class within the DLL, and this is the class heading. It's a class, give it any name you want. Okay, this is user defined, but it's appropriate to call it DLL iterator because it's going to be an iterator for our DLL class. So this is the name we have given it, but this is the most important one. You have to say implements the iterator interface. So implements iterator of type T. Okay, remember our class DLL is generic. It already has a type T. So the same type is what you will put here. Implements iterator T. Okay. Now remember the idea of the iterator. At the beginning, it should be pointing to the first node in the list or in the collection. Therefore, we have a variable here, temp, which we have initialized to head. The moment you create an object of this iterator or DLL iterator, it will have a temp variable pointing to head, exactly as you can see in this diagram. So once you create a DLL iterator object, it will have temp pointing to head. Okay, good. Now we need to implement the three methods of the interface. Let's start with the hasNext. Remember, hasNext is supposed to keep returning true as long as your temp or your pointer has not reached the end of the list. So in our case, it makes sense therefore to say return true as long as temp is not equal to null. Because you see right now temp is not null. If it comes here, it is not null. If it reaches here, it's still not null. Reaches here, it is still not null. But after that, if you move it to the next, it will be null. So it makes sense therefore to say hasNext will be implemented by simply checking what is the condition of temp. If it is not null, return true. If it is null, return false. Okay, this is the idea. Okay, what about the next? Remember what we said in next method, what it's supposed to do? The next method has two functions. First, it's supposed to give you the current element, the info yani, being referenced by temp. But at the same time, it should move temp to the next. Now we know that if we put a return statement at the beginning, then that will be the last statement in your method. So we have to actually save this variable first in a temporary variable, then move temp to the next, and then we return the value. This is exactly what the next method here is doing. So it obtains temp.info. This is temp.info. Save it in a variable of type T, of course, because the type of elements here are of type T. So save the temp.info in a variable of type T. We are calling the variable here info. Doesn't matter the name you use. Okay. Now move temp to the next. Okay. So temp will move to the next node. Then return info. So it's going to return 6. So if the user print his iterator.next, he's going to see that 6 is going to be printed. Okay. If he calls next again, he will get 5, and temp will move to the next node. And so on until we reach the last one. Okay. Even here you can see hasNext will return true because temp is not null, it is pointing to this node. So if the user say next, he will get the 10. But at that point, if we say temp becomes temp.next, you can see temp.next is null. So actually temp is going to be null at this point. Okay, so that if the user call hasNext, he will get false because temp not equal to null is going to be false. It is equal to null. This is the idea. So this is how we implement these two methods, hasNext and next, for our DLL class. Now, as I mentioned earlier, to completely implement the interface, we need to implement all the methods. But in our case, actually, we don't need the remove method. So what do? We are lucky it is void method, so you can just put it there, but don't put any code. So the Java system will assume it has been implemented, but we know we didn't put anything really, just the name. Okay, so this is how we're going to do it in the DLL class. And before I showed you the next interface, let us actually practically see how this is done in our DLL class. You're going to see this in lab 3. Okay, so I have within the DLL class, this is the same DLL class that you are familiar with from the previous lecture and labs. But now, in addition to the DLL node as an inner class, I now have another inner class. Okay, it is DLL iterator. It implements an iterator, and it is doing exactly what we have just discussed in the slides. Okay, it has next, next, and remove. Okay, good. But this is not enough, because remember, the user classes, how do they obtain an object of the iterator? They will be calling a method called Iterator. So you need to define that method, okay, with exact signature, as we already explained. But this method, all it is going to do is it will create an object of the DLL iterator and return it. Okay, so now after creating our DLL object, we can call this method, and as you can see, it's going to give us an object of the iterator. So it is that object IT that we will use to go through our list. Okay, I'm going to show you that it actually works by making minor modification to our test integer DLL. Okay, so this is our test integer DLL, the same one that you know. Okay, creating a list of integer and providing the user options. Okay, the only additional thing I made here is I have added an option called print sum, because I'm going to use an iterator to find the sum of the elements that the user is going to add to the list. So this is the method I have defined. Okay, static int sum is going to take a DLL of integer as argument, and it's going to try to find the sum of the elements inside that list. So how is it going to do it? It's going to ask the list, give me your iterator, and it's going to save it in a variable of type iterator of integer, because the list is list of integer. Okay, and then it will find the sum exactly as we explained before in the example of ArrayLists. So initialize sum to 0, and then use a loop while iterator has next, get the next and add it to sum, get the next and add it to sum, so that at the end you just say return sum. Okay, so I have a case here. I will change this to just sum, because I have another version which I will explain later, but let us call this one which we obtain using the iterator. So case 8 in our main class is going to say the sum of the element in the list is sum list. So sum means call this method, and this method, as you can see, is going to use iterator. Okay, so I'm going to run this example quickly to show you how it runs. So let us say run file. Okay, let us add some elements. So option 1 to add, let's say 5, add 4, add 3, add 2, and add 1. If you print all, option 3, you will see that it will print 1, 2, 3, 4, 5. Okay, so these are the elements in our list. Now, to get the sum of these elements, just call option 8. Okay, so option 8 is telling you the sum is 15. So you see now our iterator is working exactly like the one in ArrayList. This is how to make a class to provide you an iterator. Let us now move to the next interface, which is the Iterable Interface. The Iterable Interface consists of only one method, as shown below. Okay, so public interface Iterable, and I'm sure you will find this very familiar. because the method of the Iterable actually is just the iterator method. So iterator method will return to you an iterator object. So this is the interface. Okay. The Iterable interface normally is implemented directly by the collection. Okay, and not as an inner class in the collection. So it is not implemented like the Iterator interface. Iterator interface, we implement it as an inner class. But Iterable, the class itself, like the DLL, in its heading, it will say implements Iterable, and it will have the method Iterator inside it. Okay. So that's what I'm saying here, that for example, the heading of the DLL class is modified as follows to indicate that it implements the Iterable interface. So we're going to modify our DLL class. Before it was simply class DLL of type generic type T. Now we're going to add implements Iterable. Okay, so this is the idea. And the iterator method of the Iterable interface, as we already know, it simply creates and returns an instance of the iterator interface, or the class that implements the iterator interface. Okay, so as we already saw also, to implement this method, meaning to implement the interface, this is all we need to do. And we have already done that, if you recall, because there was no way we could test our iterator object without having this method. Okay, so in fact we have already implemented the Iterable interface. Just we didn't say so, because to say so you have to go to the heading of the class and say implement Iterable. Okay, yeah, it is therefore clear that to implement the Iterable interface, as a precondition, your collection must first have an inner class that implements the iterator. Okay, because you can see the method which is required by Iterable is returning an object that implements iterator. So you cannot implement Iterable without first implementing iterator. Okay, I hope this is clear. Good. I'm going to go back to the Java code just to emphasize this point. So our DLL class actually has already implemented the Iterable interface. Just that because it has implemented the iterator method. This is the only method required by the interface. All you have to do, therefore, which I have already done I just didn't show you, is to come here and add implements Iterable. Because if we have the iterator method, automatically we are implementing the Iterable interface. So you have to come here and add that. Okay. Why do you have to add this? Because actually our previous example can still work even if we don't say that. Let me show you that. Okay, but the next example I'm going to show you will not work with that. So this is fine. I think the problem is going to be in the test class. Okay, we're going to have a problem with the second example I will show you after I explained before each. So suppose we comment this one, we didn't use it anyway. Just to show you our class, our iterator will still work even without implementing the Iterable, because we are only calling a method, and that method will give us the iterator object. Okay, so if you run our code, it is still good, and even without saying implement the Iterable. Okay, the point I'm doing this is to show you what is the advantage of saying implement Iterable. Okay, if you run the code, it still works perfect as before. Okay, You can add element. Let's add only 2 this time. Let's say 1 and 2. Okay, the elements are 1, 2, and 1, and their sum is 3, as you can see. So there is no problem so far, even though we didn't say implements Iterable in our DLL class. It is exactly as before. So what is the advantage of saying implements Iterable? This is what takes us to the for each statement. Okay, so let's talk about the for each statement. A precondition for using the Java's enhanced loop, which is also called for each loop, is that a collection must implement the Iterable interface. Before you can use for each, you have to go at the top of your class and say implement Iterable. If you don't do that, the for each will not work. Okay? In fact, behind the scene, the for each uses the iterator to traverse through the list. Okay, so in other words, the for each is actually just a shorthand for using the iterator object as we have used it now. Okay, in other words, the following two methods are exactly the same, even though the one with for each looks simpler. Okay, so we have already seen the sum method. It takes a list of integer. It obtains the iterator object by calling the iterator method, and it uses a while loop while it has next, it.next, and so on to get the sum. So this is very clear. Another way we can use to define this method or to implement this method is to use for each, which I'm sure you know it from Java, from Programming 2 course. It's much easier to use for each to iterate through a collection. So if you are using that, you just initialize your sum to 0, and you say for each integer n in the list. For each integer n in the list, add n to the sum. Okay, this is how we used to do it. If you remember in the Programming 2 course, to traverse through a collection, you just use for each. Okay, but this can only be used if your class implements the Iterable interface. This is the point. Okay, I'm going to show you this in the example that we are looking at. You see, right now our class is not implementing the Iterable. Therefore, in the test class, if I uncomment this second method, you see that there is an error. Okay, if I hover along the arrow, you will see what it says. It says the for each is not applicable to the expression of what is required is the class must be iterable. It must be iterable before you can actually use for each. Okay, so it means all we have to do now for this error to go away is go back to our DLL and say implement iterable. Okay, save your file, and now if you go back to the DLL, you will see that the error will be gone. Okay, yeah, you see the error has gone just because we say our class implements Iterable. Okay, yeah, so now if I replace in the main method, if I replace sum with sum2 so that I'm calling this method, you see that the result is exactly as the one with sum. So if I say run file, and I enter some values, let's say 2 and 1. So the sum is 3. If you print the elements, you see that they are 1 and 2. So option 8 will tell us the sum is 3. So the two sum methods are exactly the same. And that is the point. Before you can use for each, your class must be iterable. Okay, so even though our class has all the code needed for it to work, it will not work because you didn't say implements iterable. Okay, the final point is, what is the advantage of implementing the iterable interface? I'm just going to list some points just to summarize the lecture. The following are some of the advantages of implementing the iterable interface. Number 1, it allows your collection or your data structure to be traversed from another class. Okay, the point is we have been traversing our data structure inside the data structure itself. Like in the DLL class, we have method like print all, method like find. So this method are traversing the list, but they are using the variable head. Initialize temp to head, and then you will be saying temp.next, temp.next. But the problem is, what if you are in another class? In another class, head cannot be used because it is private. If you look at the code of the DLL, the head and tail, they are private. So you don't have access to this from another class. So there is no way you can define temporary variable and say it becomes head, because head is not accessible. So your only option, if you want to traverse your data structure from another class, is to actually use the iterator, or to use for each to traverse through the list, as we saw in the case of the two sum methods. One of them was using iterator, and the other one was using the for each. Okay, so this is the first advantage. Let's continue. The second advantage is that we can now use for each, because if you don't implement iterable, as we saw, you cannot use for each. Okay, you may be able to use iterator if you have it, but still you cannot use for each unless you implement the iterable interface. And the final point is that it allows operations that are type specific to be implemented outside the collection. The point here is, if we wish, for example, we could have defined the sum inside the DLL class itself. So we don't need any iterator or iterable. Just start from a temp equal to head, get the next element, add it to sum, and so on. But remember, the DLL class is supposed to be generic. So if, for example, a user creates a DLL of students, you can see that the sum method will not work because the elements are not numbers. So you cannot define the sum method inside the DLL class. It's type specific. You have to define it outside the class. If you are defining it outside the class, you need to find a way to go through the elements one by one, as we saw. And we were able to do that because we have the ITrouble interface. So we can just use for each to implement the sum method, but not in the DLL class, in this case inside the main class. So these are some of the advantages. We will take more examples in the lab 3, that is. Thank you very much.